All right, geometry. We're moving around along to section 10.2, which is trapezoids, rhombus, and kite. There's going to be two formulas in this section, one for trapezoid and then rhombus and kite. They kind of share a formula for area. So only two formulas, but three different shapes. Okay. So starting with a trapezoid. Now, when we've talked about trapezoids in the past, we've had like regular old trapezoids, like that maybe look like, I don't know, like this. Okay. By definition, a trapezoid just has to have one set of parallel sides. So, like, let's say in this case, the top and bottom would be parallel, but these two sides aren't necessarily the same length. If they were the same length, like which is the trapezoid that you probably are you know, comes to mind when you think of trapezoid, where these two lengths are the same, this one is called an isosceles trapezoid. Okay, so this area formula will work for either one of these. It doesn't make any difference which one is which. Okay, this is not an isosceles trapezoid because you can kind of see that this side is probably longer than this one, but it doesn't matter this formula. Okay, so the area of a trapezoid, I'm going to start with the area of a parallelogram again. So base times height is the area of a parallelogram, but for a trapezoid, so this is obviously the height, and the height is that perpendicular height, so it's never that slanted height, just kind of like we talked about yesterday. But now this trapezoid has two different bases. It has this top base and it has this bottom base, okay? So what I do is instead of using just one base, I find the average of the two bases, okay? So to find average, I add them together. So I take the base 1 and add that to the base 2 and I divide by 2. That's how I find the average, right? So instead of using b, I'm going to use base 1 plus base 2 divided by 2, okay? Now, another way of writing base 1 plus base 2 divided by 2 is 1/2 of base 1 plus base 2, right? That's another way of writing this statement right here. So I have 1/2 base 1 plus base 2. That's going to be my base now, and then I just need to multiply that by my height, okay? So it's like taking the average of the two bases instead of just base times height, okay? And so they write it over here like this. They put the height first instead of base 1 plus base 2, but that doesn't really matter. So they've just taken this height and they've just lumped it over here. So that's just kind of how the trapezoid formula works out. They're going to have us just do the area of this one. So one of Brianna's trapezoid-shaped totes is shown below. Find the amount of material you'll use to make the side shown. So they just want the area of this front side. So area is 1/2 of the height times base 1 plus base 2, if I rewrite that formula out here. And let's go ahead and plop stuff in. So 1/2, the height is that 30, okay? And then base 1 plus base 2. Now, which one is base 1 and which one is base 2? It doesn't really matter. So I can call the top one base 1, the bottom one base 2, or vice versa. It does not matter which order you go in, okay? Because in the end, I'm just adding both of them together. So 28 plus 58, and then I'm going to go ahead and just simplify. So I like to do this first. 1/2 of 30 is 15, and then 28 plus 58. Try to do as much of this in your head as you can. This is going to be 86. Okay, 28 plus 58 is 86. Then, in my calculator, I can do less work because I just have to take 15 times 86. I can't do that in my head. 15 times 86. I could write it out, I guess, but 1290 is what the area is going to be, and that is in centimeters squared. All areas are squared. All areas are squared, okay? All right, so example 2, Amelia designed the pennant shown for her team. Find the area of the shaded portion of her team's pennant. So they want the area of this trapezoid shape here, okay? Now, they're kind of trying to trick you in this case because they want to figure out what your two bases are, okay? Well, your bases are the ones that are parallel to each other. So your bases are going to be these two sides. So don't think base is top and bottom always. Bases are going to be your two sides. So this guy is 10. Now what's this side going to be? That's going to be the struggle, trying to figure out what this side is, because they don't label that. So I need to know what that other base is, okay? So we'll figure that out here in just a second. But then this guy right here is this 4. Okay, that is going to be your height technically. So basically, if we think about this trapezoid sitting on its side like this, the height is 4. So I'm going to put h equals 4. Let's call base 1 equals question mark, and base 2 is 10, okay? This 8.5, that slanted area right there, we're not going to use, okay? The reason why we know that this is the height is because, like, he is perpendicular to the base, okay? That 8.5 is what we're not using, okay? So how do we figure out what this length is right here? Well, okay, let's do this. I'm going to lump this top side off right here, and I'm going to make this into a triangle, okay? All right, so just go with this for now, okay? If I make that guy into a triangle, right, this side right here is 8.5. This bottom side right here is going to be a length of 4. And this guy right here, we don't know. His 10 is all the way from here all the way down to here, okay? So let's figure out what this length is. How can we figure out what that length is, okay? This is a right triangle, so I can use the Pythagorean theorem to do that. So let's call this guy A, and this guy's B, and then 8.5 is going to be my C. So A squared plus B squared equals C squared, okay? All right, and we'll see kind of how this works here in a minute, C squared. So A squared plus 16 equals 8.5. 8.5 squared is 72.25, okay? Then I want to solve for A, so I'm going to subtract the 16 over. A squared equals minus 16, 56.25, and then to get A by itself, I take the square root. So A is going to be the square root of that answer, which is 7.5. Okay, great. Now, how in the heck does that help us at all here? So this length from here just to here is 7.5. I want to know what this side is, okay? Well, this side is going to be the same length as this side, right? And how do I figure out what that one is? Well, the whole length is 10, and from here to here is 7.5. So this guy will have to be 2.5 because 10 minus 7.5 is going to be 2.5. So my other base that I don't know is going to be 2.5. So it was kind of a long process trying to figure out what that is, but you know, we can use that for the Pythagorean theorem to do that. Okay, now we just have to find the area. So area is 1/2 the height. Let me write the formula out. Times base 1 plus base 2. Okay, and now I just plug my stuff in. 1/2 height is 4. Base 1 is going to be 2.5. Base 2 is 10. And I can switch those around if I wanted to. Half of 4 is 2. And 2.5 plus 10 is 12.5. 2 times 12.5, I can do that in my head. 2 times 12.5 is 25. And that is in inches squared. Okay, so a little bit more work for that one. Okay, last thing, rhombus and kite. Okay, rhombus and kites are both going to have the same area formula. So this is a rhombus, and the definition of a rhombus is basically it's a parallelogram where all 4 sides are the same length. So a rhombus is kind of like a tilted square. Okay, all 4 sides are the same, but it doesn't have to have 90-degree angles. He's kind of tilted. Okay, and then a kite has these 2 sides are the same length, and then these 2 sides are the same length. So I mark them like that, okay? Just kind of the way you think of a kite, all right? Now, here's how the formula of a kite is done, okay? So I'm going to have you look at this first one, or the formula of a rhombus or a kite. I'll show you both. So what I'm going to do is this line that goes across here, that's labeled as D1, and D1 stands for diagonal 1. So this diagonal 1 is going across here, and diagonal 2 is this length going through this way, okay? So the area, if I'm trying to find the area, what I can do is I can take this little piece right here, this little triangle, and I can take him and I can rotate him up and slap him up on the top here to make kind of a little rectangle here, right? But then I can do the same thing for this one. I can rotate him up at the top, and I can make a little rectangle here. So what I'm trying to find when I'm doing this is I'm just finding the area of this whole piece right here. Okay, if I take those 2 guys, if I was showing this to you in class, we would actually get paper out and we would cut these and we would rotate them up. So what's happening here is I can take those guys and rotate them up to make a perfect box, okay? And to find the area of a box or the area of a rectangle, I take base times height, okay? Well, this is going to be the base, and that base is labeled as D1, right? So I'm going to take base times height, but base is going to be now, in this case, D1, okay? But the height is only this length, okay? D2 is the length all the way from here to here, right? But I'm only doing half of the length of D2. So my height is going to be half of D2, okay? So if I lump all of that together, I have D1 times half of D2, and they have reordered it as half D1, D2, okay? So this is going to be how I'm going to find the area of a rhombus or a kite, okay? I can do the same thing here for my kite. I can take this piece, and I can lump him up here to make that guy. I can take this piece, lump him up here to make this guy. And again, I have just this little rectangle that I'm trying to find, okay? Where the base, the length of the base is D1, and the height is going to be half of that D2 value, okay? So half of D1 times D2. They've just reorganized where the half goes, okay? So that's all I'm doing here is find the area of each. So it does not matter which one you label as your diagonals. It says the length from here to here is 8. That's kind of how they show it to you up there. So this is length of 8. This is length of 15, okay? Now, I can write this two different ways. I can write it half times 8 times 15, or I can write it half times 15 times 8. Now, here's the way I want to do it, okay? I try to do as much in my head as I can. So it is easier for me to take half of 8 than it is to take half of 15, right? Half of 15 would be a decimal number. So I'm going to, and it's not wrong to write it this way. You could take half of 15 and get the right answer. But I'm going to write it as this, so I can take half of 8 really easily to make that 4. And 4 times 15, think of a clock, is going to be 60. So that's 60 meters squared. Okay, do as much in your head as you can, right? Now, here's what you don't do. You don't distribute the 1/2 through for both pieces. It's not half of 8 times half of 15, right? It's just half of one of them, right? You're just taking half times that, okay? So don't distribute that 1/2 through, okay? Just take it times, that first element or whatever. Take them times it in that order, okay? So 60 meters squared. All right, last one, B, they labeled this guy as 12, okay, and this guy is 10. So be careful of the way that they have labeled these. My diagonal one, let's say this is my diagonal one here, okay? This piece right here is 12, okay? But then if I'm going all the way across, that's going to be double that. So my first diagonal is going to be 24, or double of what 12 is. My second diagonal, this is 10, so the whole diagonal is going to be 20. Okay, and in this case, I can take half of either of those, so let's just go ahead and do half of 24 times 20. Half of 24 is 12, and 12 times 20, do as much in your head as you can. 12 times 20, or 12 times 2 is 24, with an added 0 on the end, right? 12 times 20 is 240, and that's going to be in feet squared, okay? So be careful of the way that you label it. If they label it like this, then that means that the whole way across is going to be 15. But this is, only that is 12, so the whole length you have to find, okay? Oh, shoot, we have one more. Okay, one diagonal of a rhombus. Here's my rhombus. He's a tilted square. Okay, here's my rhombus, all right? So one diagonal, and then I have the other diagonal. One diagonal of a rhombus is twice as long as the other diagonal, okay? So let's label the shorter guy as X. The longer guy right here is twice as long as that. So what would we use to express twice as long? We would say 2x, okay? So 1x, and then this would be 2x. If the area of the rhombus is 169 square millimeters, what are the lengths of the diagonals? So the area of a rhombus is 1/2 d1 d2. Okay, I know that my area is 169, and I have 1/2 times d1, let's call the first diagonal x, and the second diagonal 2x, okay? All right, now, here's the deal. Let's simplify this side over here. So I have 169 on that side, okay? If we simplify this over here, half times 2, half of 2 is just 1, right? So those just kind of cancel each other out. But then I have x times x, which is x squared, okay? So I have 1x squared there, and then to find out what x is, I would take the square root. Okay, so x equals the square root of 169, which you probably should know that in your head, is 13. Okay, so this diagonal will be 13. So my diagonal 1 is 13, but if the other one is twice that length, the other diagonal, or diagonal 2, will be double that, 26. And both of them are in millimeters. Okay, Now, these are not squared because we're just finding the lengths. We're going from the area backwards to find the lengths, okay? So the hardest part is getting your diagram labeled as what your variables are going to be, but after that, it's pretty well plop them into the equation, work backwards, okay? This is a good reference page to come back to if you forget your formulas, because they have, you know, parallelogram, triangle, trapezoid, rhombus, and kite. These are the ones that we did in 10-1. These are all 10-2s. So if you need one place that has all of those formulas, here it is right there. Okay?